Welcome everyone to GSEU Day. My name is Julie Hollis and I'm the Secretary General of EuroGeoSurveys, an international not-for-profit association representing 37 geological surveys of Europe, almost all of whom are partners in our flagship project, the Geological Service for Europe, together with other geological surveys and academic partners. So today is about getting you involved in our ambitions for a geological service, a pan-European expert network supported by harmonized data, information and knowledge about Europe's subsurface. So today we're not just focusing on what we've been doing and what we want to do, but we also want to focus on what you want, what you think is important, and how we should be including you and others in our path towards supporting a green transition through this project and a future sustainable geological service for Europe. So this is your opportunity to influence our direction of travel. So a Geological Service for Europe, it's the name of the project and it's the name of our ambition as an association. We see that our job through such a project, through such a service, is to deliver the geoscience that is necessary to deliver the green transition, and also to translate the geoscience into language and tools that can inform and contribute to implementing sound policy. So the knowledge that geologists have of Europe's subsurface and the voices of geologists are crucial for the Green Deal. Why? Well, most people know that geologists are the scientists who know about mineral resources, yes. But not so many people know that geologists also know about groundwater, for example, which is the water in the rocks beneath our feet, which delivers a quarter of the water for our agricultural soils, around 65% of the water that Europeans drink. And not many people realize that geologists are also scientists who know about renewable energy, geothermal energy, the heat that's stored in the rocks beneath our feet. And what about energy from wind farms? Well, it's also geologists who understand the rocks that make up the marine substrate, the shallow ocean floor, and so are able to advise on where it is practical to locate wind farms. And it's geologists who understand the changes in climate conditions that affect our coastlines, where 40% of Europeans live. Unfortunately, geologists, and there are lots of them in the room today, we're often not in the best position to make our voices heard because of this fact that most people don't know what we do and why the data and information and knowledge that we have is integral to delivering the Green Deal, and not just the Critical Raw Materials Act, but diverse Green Deal legislation that cross-cuts policy sectors. Our hope is that you will leave the end of today with some renewed momentum and eagerness to partner with us in achieving a geological service for Europe as the foundation of a sustainable future for Europe. Thank you.
In the morning, we'll give you like some short pitch of the type of working we are doing. So our focus for this moment was to give you an idea, a clear idea of the type of product that we believe is extremely valuable for you. And at the end of the morning, we'll also have like a first session with a panel discussion about the GDI platform. A lunch break, I don't go too much in detail because Tracy will explain later better how it's going to work. We're going to have a poster competition and in the lunchroom art exposition of a very good friend of us. And in the afternoon is the moment in which we really need this audience to be extremely engaged with us. So we're going to have a few sessions with a short introduction from the moderator, and we have a beautiful list of external speakers of the GSEU project, one of our main stakeholders. And then we are going to have a 20 minutes panel discussion for each session. And please, please be engaged with us. Don't be shy, ask our questions. We are really here to work with you. You all have the agenda, so I'm not going to go through in detail through everything. I think, Justine, you can put on the next one. So I was thinking, first of all, how to make an overview of 1 year of a huge amount of work from the GSEU consortium. So I thought about doing it in 4 words. The 4 words was validation, because I love the picture, so I feel very close to myself about that my life is much more interesting inside my head. But we really went to the outside world because we really believe that there is a need of what we are providing. There is a need of high quality data of the subsurface. There is a need a pan-European effort because the solution that we are looking for do not belong to a single state member. But then we really went to many events, many roundtables, talked with many organizations just to check if the answer that we are giving to this question was the same for everybody. I'm not going to tell you what the answer that we found. I hope that you find the answer at the end of the morning presentation from my GSU colleague. The second word that impressed me this first year is impact. And I love to say that no one gets remembered for the things they didn't do. So we really want to do stuff. We really want to do things now. And things are not perfect is not important. We really want to go out to our stakeholders, and then they give us feedback, and that we make it better and better and better in each interaction. We know that what we can provide is something extremely valuable, but we also know that we don't have the answer for every question, or we don't have the solution for every problem. So in this first year, we engage a lot of, we're starting a lot of collaboration from profit and non-profit organizations, for example, for combining subsurface data and on-surface data about infrastructure for optimization of the energy sector, or with several DG, or with different private entities. So we know that to reach the net zero target, we need to have a collaborative effort. Last word is ambitious, in the sense that we have a huge amount of work ahead of us. We have a huge consortium to work together, and one thing that we have learned in the first year, that ambitious is very important. Over-ambitious is too risky. So one thing that we did in the first year is also to reprioritize our activity to make sure that we can reach an impact before 2027. And the discussion that we'll be having today with you is also very important for us to understand if the new priority that we make are the correct one. This was already my first year in 4 words, and I think now we can start with our fantastic colleague from France, that is the group leader of the work of GSU. Oh, sorry. Oh, I'm very sorry. We are not started yet with our colleague from Critical Raw Material. I will ask Julie to be back on stage for a presentation. Thank you, everybody.
Where do I point this? Sorry. Here we go. All right, so it's my job now just to say a few more words about why do we need a geological service for Europe, and what is that anyway? So I wanted to start with geology. What's geology? What's that? And unfortunately, as I mentioned already, not many people actually know what geology is or what geologists do. They know that geologists study rocks, which is true, but that's a very narrow view of what an understanding of what geologists do. And there are a number of reasons for that, but probably one of the main ones is that geology is not generally taught in most schools anymore in many countries in the world. It used to be taught much more commonly, but now it isn't. And so many people only end up with a reasonable knowledge of geology if they stumble across it at university, which is what I did and how I became a geologist and how a number of other geologists I know also discovered geology. And it's a bit of a problem for us when we're trying to emphasize that geological data and information and knowledge is actually crucial to the Green Deal, to our goals now more than ever. And why are they crucial? It's because geologists don't just study rocks, they study the earth. So there are a lot of geologists in the audience today, so I thought I might ask a few of them what they do. So let's start with maybe Klaus Hinsby from the Geological Survey of Denmark and Greenland. Klaus, what do you do?
Julie? Well, I'm doing my best to contribute to improving our understanding of water resources, quantity and quality, to protect our drinking water resources. That was the primary reason for us for many years, but increasingly now also with the water framework and groundwater directives to protect nature and biodiversity. So I'm doing my best to do with it as co-chair of the Water Resources Expert Group in EuroGeoSurveys.
Thank you, Klaus. Maybe you could pass the microphone to Christina. Christina, what do you do?
From the German Geological Survey, which is BGR, the Federal Institute for Geosciences and Natural Resources. And what I do is, together with an international team, with several international teams, I compile and harmonize geological map information across political boundaries for the whole of Europe, on and offshore. And as a base for this, we are also in our groups compiling vocabularies as a sort of common language that the geology can be made understood across political boundaries and as a base for harmonization. This is what I do.
Thank you, Christina.
Thank you.
All right, and maybe I'll ask one other person. Serge? Serge, there you are, yes. What do you do, Serge?
Yes, Serge van Gessel, TNO. As a geologist, I'm leading a team of international experts to understand the feasibility of hydrogen storage in the subsurface. And as an advisor, I'm helping, building bridges between scientists and the government to, understand and support decision-making and governance on how the subsurface can contribute to energy transition. Thank you.
Perfect, right. So it's very clear just from these three people that geologists do a wide range of different things. They study a lot more than rocks, and indeed the Earth is a lot more than just rocks. It's the water in the rocks under our feet, the groundwater that Klaus was talking about. It's the health of our soils that they study, the soils that we use to grow our food. It's the suitability of the subsurface for storing carbon dioxide, hydrogen fuel or energy, and much more. And so when it comes to the Green Deal, a knowledge of all of these things is crucial to achieving the goals of the Green Deal and reaching net zero by 2050. And what's also important is that it's not just feeding the data and information and knowledge about the subsurface through an open, user-focused knowledge infrastructure, which we are doing, but also understanding the relationships between all of these things and the processes that control them. Because although policy must necessarily define and categorize processes and activities so that legislation can be written to guide our actions and to guide our industries, the Earth cannot be neatly subdivided into categories. And once you look in more detail, of course, water and energy and minerals and subsurface pore space where we want to store things, fuel and energy and carbon dioxide, these all interact with each other in the subsurface. And in recent discussions within the EuroGeoSurveys network, one unifying wish of our experts is that they want to achieve more interaction between scientific thematic areas. They want to move away from siloed behaviours and activities and towards more integrated thinking about how to solve environmental and societal challenges that geologists must contribute to. And this is a development that I see as particularly positive, this wish to collaborate, which really defines the essence of EuroGeoSurveys, the Geological Surveys of Europe, and which is the association that is coordinating the Geological Service for Europe project. Collaboration has been at the heart of EuroGeoSurveys since it was established more than 50 years ago, and today I feel it's the case more than ever. This spirit of collaboration must extend beyond our geoscientific community to the EU institutions and society that we serve. Most European nations, indeed most nations, have a geological survey which informs and advises at national level on these many environmental and economic and societal challenges. But as long recognised through the collaboration in EuroGeoSurveys and through the establishment of the pan-European harmonised geological data infrastructure, serving the national level is not enough. Because the natural environment that we live in does not stop at national borders. Groundwater does not stop at national borders. The geological resources of one nation which can extend into another and can serve other nations, minerals, geoenergy, water. And just as communities collaborating can achieve much more than individuals, so too at continental scale we can achieve much more than we can at national scale. To address continental scale problems, we must act on continental scale, and to do so we must also think on continental scale and deliver data at that scale and deliver solutions at that scale. In terms of our natural environment, in terms of the earth that we live on and from which we draw the energy and minerals and water that drive our society, national borders are meaningless. And that is why we need a geological service for Europe. Because the earth is an interconnected system of processes, and to develop and implement the best Green Deal policy, the geological knowledge of the many aspects of these interconnected processes, this interconnected system must be understood and effectively translated so that policymakers can deliver through sound, complementary science-informed policy the best possibilities for us to achieve net zero. Thank you.
Thanks a lot, Julie. Okay, now we can start with Guillaume Bertrand for BRGM. So please, Guillaume.
All right. Good morning. My name is Guillaume Bertrand from BRGM, and I'm coordinating the raw material actions in the GSEU, and that's what I will briefly present. I think I have less than 7-8 minutes, which is a challenge in itself. So I will try to be brief. All right, next slide, please. Oh, I do it myself. Okay, great. Thank you very much. I keep saying that we are living in a changing world, which is kind of obvious statement. Actually, the world has been changing forever, I could say. In the past centuries, we have needed and we have used more and more mineral resources. With the evolution of the population, the evolution of our ways and level of living, we have consumed more and more natural resources and mineral resources, both in terms of volumes, but also in terms of variety, more and more commodities. But recently, today we are facing crises, for instance, the climate crisis that impose transition, the energy transition, the digital transition, that require huge amount of raw materials, including critical raw materials. So actually, this trend that goes back to, well, a lot of time is increasing, and our need for raw material is surging, and it will keep surging in the future. That's one point. All right. Another important point is that in Europe, we largely rely on third countries for our supply. For instance, the lithium we use in Europe, 79% of the lithium we need comes from Chile. 63% of the cobalt we need comes from the Democratic Republic of Congo, and almost 100% of the heavy rare earths we are using in European industries comes from China. So that's a challenge. That imposes a threat on our industries, especially in an unstable world that is that we are facing today. The good news is that we have a potential in Europe for many raw materials, including critical raw materials. Actually, there is a kind of double paradox here. Europe is an old mining continent, but still, we have a significant potential in Europe. That's the first paradox. The second paradox is that despite the fact that geology of Europe is quite well known, we are still missing data. If I take the example of France, for instance, in the previous mining inventories of the countries, we have not been studying lithium, for instance. So we know very little about lithium. We are missing data, and we need to acquire, compile, and provide data. And that's the core mission of the GSEU Raw Material Group. It's to provide high-quality data and expertise to help relocate critical raw material supply in Europe. To do that, oops, I went too far. All right. To do that, we are working both on onshore and offshore mineral resources. Offshore, of course, because for some CRMs, critical raw materials, the potential of offshore resources is very significant. Of course, before thinking about extracting these resources, we have to carefully assess the impact of such extraction in terms of, among other, environmental impact. We are also, working on onshore resources. There we are working on two axes. The first axis is data itself. Compiling, collecting, harmonizing data at the scale of Europe is a challenge in itself. Hopefully we are not starting from scratch. We have infrastructures that exist and that needs to be developed, but the data is scattered among different data sources, databases, countries, etc. So that's a challenge in itself. That's the first axis. The second axis is the that slide. The second axis is the valorization of this data in terms of information, knowledge, and expertise. That's very important. In the form of assessment of potential, for instance, in the form of added value products, such as maps of CRM deposits on the right, or maps of favorability on the left. If you're interested in this, I invite you to have a look at that poster that is just over there, and we can discuss in front of that poster during the break. I won't go into detail. Potential, assessing the potential in Europe for CRM is one point, but managing the resources, another one point. So an important task in the GSEU raw material work package is to develop an international center of excellence on sustainable resource management. It's going to be a capacity building and knowledge center to support the UNFC, United Nations Framework Classification System, and the United Nations Resource Management System. It will help supporting resource management at EU, national, and regional scale. Here, UNFC is very important and is the topic of another task of our work, because UNFC is a tool to assess, among other possibilities, it's a tool to assess the maturity of the projects. And as such, it's important to identify which are the projects that are the most mature and which are the projects that could, in the near future, supply CRM to European industries. So just to summarize and wrap up this short presentation, we are facing challenges. But the good point is that the awareness on these challenges is now quite high, and there are ambitious steps that are taken at the highest level of the, for instance, the European Commission. As a consequence of this, there are strong expectations on the raw materials topics. Time is a key issue. If I refer to the Critical Raw Material Act, the time frame is 2030. That's a challenge. We need definitely data and expertise, and GSEU until 2027, and after that the future Geological Service for Europe will be able to provide information and data to face these challenges. Thank you very much.
Thank you again, Guillaume. This morning we want to really have a very agile process, so please, I'm sure that you have a lot of questions for Guillaume. All our morning presenters will join the panel in the afternoon. So now I'd like to move on and ask our colleague Paula Cantelli from Geological Service for Spain to give you an overview of the geoenergy resources.
I think that I prefer there, just in case. Thank you. Hi, good morning. I will try to optimize my 7 minutes and be really efficient. So we don't need to explain you how important are the green energies right now, and in this green energy transition that we need to frame at the national and the European level. So I will jump directly on what we are working with and the products and the information that we plan to produce for you. In the GSEU, when we talk about geoenergy, we talk about a sustainable geoenergy capability. That means that we are looking for to identify the potential for permanent CO2 geological storage, hydrogen and compressed air temporary geological storage, and geothermal energy. That means including deep geothermal, shallow geothermal, and UTs, underground thermal storage energy. And we will do it in 2 levels. At national level, providing a platform which will be a gate for access to all national databases and maps, and also to European level, producing the Pan-European Atlas. And when we talk about Pan-European Atlas, we are thinking in reliable data, harmonized databases, European scale maps, and thinking that we need to produce information, technical information useful for evaluate the potential, but also digested this information to support to the decision makers. Also, we will produce and publish and offer all the knowledge that is behind. That means the procedures, the methodologies, vocabulary, everything, because we know that knowledge is important. Transfer the knowledge between the members, because not all of the members go to the same speed, and we need to help each other to move forward, and also outside of the EGS, because it's important not only to produce knowledge, but also to be reproducible. All of this knowledge share will be included in which we call the Knowledge Hub. So, So the first point, the CO2 storage, is our first pillar. We have a European map of the CO2 potential coming from the CO2 stop. But this information was released in 2014, and some of the information comes from the Geocapacity project from 2006. So it's really no update information, and it's used in many cases for updating the potential in Europe. So we will update this information. We will include the mature one that there is in many projects in many countries, and we will include also new projects, new countries. The information is organized in 3 levels. The first level of formation, that is more wider, the daughter units and the storage units. And that is important because we can classify later according to the storage readiness level. That means we can categorize according to the maturity of the information. And that is really important because we can compare apples with apples, something that is not happening now, that they are comparing capacity estimation in one cases, really mature information with other that is not. And we will be able also to produce this information knowing which activities are needed for really deliver this storage capacity. That means investment and means time, which is fundamental for the planning and for the strategic decisions. The second pillar is the temporary hydrogen and air compressed geological storage. Our starting point will be the high storage. It was finalized last year, but released before summer to the public. Really, the information is updated, but we have now some years, at least 2 years, for updating more information if something is coming. We can include new countries that have not been included in this work. And we can include also this storage readiness level applied for the hydrogen. This high storage was built based in the same structure that the CO2 stop. That means that it's very easy to compare one with the other, thinking in the competition of the subsurface. Our third pillar is the geothermal energy, and that includes the deep geothermal, shallow, and UTIs. Talking about the deep geothermal, we are not so lucky, let's say, like in the other 2 cases, because we don't have this pan-European atlas as a starting point. A 6th one European atlas, but was created 30 years ago, updated 20 years ago, and is in paper. It's not digitalized. There are a lot of information, a lot of knowledge in Europe about deep geothermal, and what we plan is to produce a new map based on existing information and with 3 levels of knowledge. First level, including the geothermal place and explaining the potential and potential uses, to the 3rd level with more level of maturity and level of information with the assessment potential. In the case of the shallow geothermal, there is a lot of information, local, regional, national, but we need to think to European scale. At European scale, we will produce a favorability map of the technical applicability of the open or closed loops. That means that a decision maker can select one or other technology depending on the efficiency. That means more energy, less investment. And in the case of the UTIs, we will produce a suitability map to select the potential of storage, thermal storage in the low temperature, depending on the features of the reservoir, plus the balance, the energy balance of the demand. knowing that there is a competition of the subsurface, as was mentioned by Francesco before, is fundamental to understand what happened in the surface. Because to optimize and use one or the other depend on the demand and what is needed in the surface. So one of the key points that we are thinking and we are working this is creating this map and this information, align it with existing databases in the surface, as this is the case of the Joint Research Center. That is only one, but we are working very close to really can be both things compatible. Just the last one, to remember that all this work is possible thanks to the high commitment of the members of the Work Package 3 of the EGS, and also the collaboration with other institutions, other organizations, and also with the industry, because we need to work together to really deliver what is needed and what is needed in time. Thank you.
Thank you very much, Paula. He's already here with me, Peter van der Keur. He's our group leader of the groundwater resources group.
Is there a pointer as well?
Yes, this is
this the pointer.
you should point towards the computer. Point toward the computer.
How do I go back? Okay. Good morning, and thanks to Julie and others to introduce groundwater resources as a geological discipline, which is not very known to many. Fortunately, it has got growing interest. There has been the first UN groundwater summit last year in Paris, and which was followed up by the New York Water Conference early this year in March. So what I will do is give a short presentation of what are the challenges with respect to groundwater resources, and how we would like to, or how we do address this in the GSEU. I also want to acknowledge the people working on this work, Benjamin Lopez and Stefan Broder and many others in this work. So oh, sorry. Okay. So, what are the challenges with respect to groundwater resources? There's a lot of demand and on groundwater, and it has been mentioned already that there's groundwater resources constitute a large part of water consumption globally and in Europe, and the demand is increasing. Demand from irrigation, from industries, from many other sources, and so there's a need to map the groundwater resources, the data related to groundwater resources, both with respect to the quantity, which will be the first part, but also with respect to the quality, which will be the second part. You can see here, this is an indicator used by the European Environmental Agency, which shows that some countries, they use a lot of water unsustainably. You can see here, they use the indicator, which the more blue it is, the more unsustainably water abstraction is in Europe. And so how to address this, how to see what can be done on basis of reliable data, how can we address this, how can we find out how we, in a strategic and in an integrative way, can address this situation to adapt and to do something about it. And we do that, as many of the other work in the GSEU, by collecting data across Europe, because there's a lot of difference from country to country, and to harmonize this data so you can compare across barriers, across borders, and to detect trends. So if you can detect trends, then you can do something about it in time, and you can act in an adaptive and strategic way. So, as you can see from this slide, on the left-hand side, you can see what we do with respect to collecting data across Europe. So, Geological Surveys, they have a lot of data, and this data is collected and it's harmonized, so we can directly compare and use data also in places where the coverage maybe is not so large. So this is what you can see here on the left side. You can see these databases here, and what is then useful for instance, national and pan-European water authorities is to see how can we detect trends from what is already going on. So, for instance, here you can see there's an historic observed data, and we are now in the process of collecting these data and work with them, so it can be used for forecasting. So the forecasting side you can see here on the right side, from the low abstractions, groundwater abstractions, to the high abstractions. So this is the current situation, and then you can use advanced techniques. In our case, machine learning, aided techniques and other techniques to extrapolate this to the future, so measures can be taken in time in an effective way. What is then done is if you have this system in place, so where you can do the monitoring and observations, then you can integrate this into a platform to make it usable, user-friendly for the end users. So how could this look like? I took this slide to give you an impression of if you integrate this in an information platform, the EGGI, then you could see from this picture how dry situations can be different from the normal and the wet situations. This is for 30 days, and you can imagine that this is for Sweden, but you could imagine this can be done on a pan-European scale and be used by the European Environmental Agency and other authorities on a national scale as well, of course. And so this is just to give you an impression of how this could look like. And the same applies to groundwater quality. Groundwater quality, again, this is an image from the European Environmental Agency, can vary across countries, and that depends on both on natural conditions, so the geology, the hydrogeology, and so on. But it can also depend on anthropogenic influences. And so you can imagine there's a lot of difference in agriculture, in industry, and energy supplies across Europe. And this all has an influence on how water quality is different from country to country. And so what we want to do is also in this case to collect reliable data from all the participating geological surveys across Europe, and to see what are the drivers and what are the pressures across Europe, and how can we from this data make some predictions on how water quality could develop, but also to see how water quality can be dealt with on a European scale, and so. So what we then do in this project is, you can see here, it's quite similar to what we do for water quantity. You can see we collect the data again from the geological surveys, and to And of course, this collected data can be quite different from country to country on which compounds are collected and how this is done. So you need to harmonize this, and also in this case, we use machine learning techniques to get a graph like this. Oh, sorry. To get a graph like this on the right side, to see how different monitoring site can display different compounds. So in this case, it is the concentration of nitrate, but this can be done for many other places as well, of many other compounds. So the added value, as you can see here, it's we use previously collected information and collaborate with all the different participating geological surveys and to get this done. So a very similar approach to the water quantity and quality in this case, and yeah, so the anthropogenic groundwater phases you can see here. So you can see the different colors in this graph, and you can see that this may be due to industrial aspects, or it can be urbanization. It can also be due to agricultural use, and can also be a natural cause. And that's it, what I wanted to present for the Water Resources Group.
Thank you very much, Peter. Our next speaker is Sitze van Eteren, colleague from TNO, is going to show us the work on coastal vulnerability and offshore wind farm siting. Welcome, Sitze.
Thank you, Francesco.
Green and point there.
Green is forward, right? Yeah. Just wanted to tell you that I'm a task leader within Work Package 5, which is led by Eleftheria, who's there. Maybe you can stand up so everyone knows who's leading our work package. So now, what do these two WP5 topics have in common? And why are European stakeholders asking us as geological survey organizations to work on them? Well, this is all about climate change. We need to prepare and we need to prevent. And geological surveys have a very important role to play in this. Oh. There we go. So we as geological survey organizations have been very good at making descriptive pan-European maps that show the geology as a surface. So the pictures we saw before, they're very flat, obviously, but geology is not flat at all. And EMODNet, the European Marine Observation and Data Network, is a very good example. And I think we've been successful in finding a common level as European Geological Surveys. But in Geological Service for Europe, we want more. We don't want to find a common level. We want to raise our level and find best practice. So this is what we anticipate to do in Work Package 5 as well. Aside from getting all these pretty pictures that only tell us half of the story, we want to dig in. We want to move from 2D to 3D. We want to take the time to start sharing amongst ourselves how much we understand. And it's also time to show how that helps everyone else, everyone here in Europe and everyone here in the room. I'm pressing very hard on the green button. So I guess it's one of my weaknesses. So how can we make this happen? I'm immediately talking about those weaknesses, but turning them around. We need better compilation. We need better formatting. We need better applicability, better demonstration, better participation. So we need to show that we can explain and predict what has happened over the past years and decades. And together, we can help reduce risk and reduce costs associated with climate change and the solutions we have to fight it. So we need to cooperate. It's fun to cooperate, and it also serves a purpose. So it brings these two things together. So the first issue we're tackling in Work Package 5 is coastal vulnerability. And why is coastal vulnerability such a hot topic? Not just amongst geologists, but overall in Europe. Well, we as European citizens are very susceptible to disturbances resulting from coastal hazards. They threaten our safety, they threaten our economy, they threaten our health, and they threaten our environment. So all important issues that we all want to have as well as we possibly can. And geology is involved in all of these. So we're looking at how geological and hydrogeological parameters are connected to ground motion. We can't wait to find out which superficial and subsurface conditions and processes matter most in which European domains, because it differs over Europe. How geology can be used to explain and predict subsidence as well as uplift. Often we leave this to engineers who look at satellite images and say all kinds of things, possibly using some of our flat maps, but we know what's underneath and we have to contribute it. It's starting to look and go a lot better now. So what is the big deal about finding suitable locations for offshore wind farms? Well, it's very simple. We don't want them in our backyards, and the number of turbines is going to explode. Plus, there's competition for space. So from this perspective, we need to put things together. It's about both the surface and the subsurface. And we find out which geological parameters are important enough to address as a group across Europe. I think this is an old presentation, so I'm turning around a little bit. So together, we'll come up with the best practice for sharing what we know, for making sure that our knowledge is used. And we're not alone. You're all here because you want to help us. And EMODNet is especially important to us as marine geologists. It highlights our mapping work and it connects us to other disciplines. But other partners, more regional and local, are important as well. We need to go all the way from the big Green Deal to small business. We need to make sure that people have all the tools and knowledge to make the right decisions. And the final slide. Thank you.
Last speaker before the break is someone that I never bored of listening to. So when I saw his draft presentation on Monday, I extremely enjoyed. So this is Chris Pissen for Geological Survey of Belgium, and he's going to tell us something about the bare necessity of geological mapping.
Yeah, thanks, Francesco, for raising the pressure a little bit. Today, this presentation, we're going to do something that we've never successfully achieved before. And that's convincing you, audience, that what you want is a geological map. And we don't need that much to actually convince you. We've got the Earth, very important. We've got you, equally important. And that's enough to ask us one very fundamental question. How do you stay alive? And, well, oh boy, I've got so many animations. Yeah. And in order to do that, in order to survive until, let's say, the next, let me try another way, because I've got a lot of clicking to do in this presentation. Whoa. Yeah. In order to make it, let's say, until next morning, you will need to find shelter, you will need to find food, you will need to find things such as chocolates. And I'm very confident that each and every one of you will be able to make it until tomorrow morning, because your survival skills are all excellent, at least as long as you stay above ground. It's very important to also realize that everything that's here on this slide also requires something from the subsurface. So there is a link here. What you see here is a link between anything that you need at the surface also links to something in the subsurface. And if we raise a challenge and ask you to also find these resources, that means that you need to know what the geology is here in Brussels and whether that geology offers any opportunities for what you need to find. And at this moment, I see some confused faces here, like, am I supposed to do this? No, of course not, because that's why you have geologists, if the presentation works with me. Yes. And now I could, of course, the question still stays, then how does a geologist do this and achieve all of these elements? And in order to answer that question, we're going to change the story a little bit, slightly, and replace our geologist by a rather primitive person that is always hungry, and therefore always on the hunt for food. And it is in bad luck because this person lives not just in an open plain, he lives in a very dense forest or a very dense jungle where all of this food is hidden. So how does this person go about in finding that food? Well, I don't have to explain you that, because you have had 4 excellent presentations telling you how to find different resources. Basically, it comes down to tracking skills. You look what data is out there, you use all of your senses, all of your techniques, and you try to pinpoint down these resources. And there's nothing wrong with doing that. It's an excellent method, but just imagine that we give this person now a map. And suddenly things start making sense. It explains why animals are here at this moment of day and migrate to another location otherwise. We've just upgraded our hunter to a prime predator. And that, ladies and gentlemen, is why geological maps are so important. And of course, you're a very critical audience and a very attentive audience. And I'm just showing this slide because you would immediately otherwise stand up and say, but we have geological maps. We've got piles of them. And that is true. But we also live in Europe, and Europe has a lot of borders. And all of these maps, they stop at borders. And I think I need an example to explain why that is a problem. What I'm showing you here is a profile that's a vertical section through the underground from Belgium to the Netherlands. And yes, I've hidden the middle part there. And you see left and right colors. And I mean, a child could basically connect these colors and trace them through. So let's see how the experts do that from both countries. And they do, well, not far from perfect job. I mean, any child seems to have be able to do that better. If you ask why this is such a problem, why it is so difficult, it's because geologists live in forests. And it's just a tough life that they have. Of course, if you realize that, if you make them work together, then they can do something very different. And they can come up with models like this, which is a very big improvement over the other one. So it's not a fundamental issue, but it's just an existing issue. And if you ask, is it just Belgium, Netherlands? No, this is all across Europe. And moreover, it's actually, you find these things onshore, you find them offshore, you find them at the surface, you find them at depth, you find them across different scales. there are even these kind of issues that we know about, but we actually haven't really documented and are doing anything about them right now. So this is really a pan-European problem that requires a pan-European effort. But it's also good news. The good news is that we have IGME 5000. And IGME 5000 is the only harmonized map where geology is harmonized across the whole of Europe. And also in view is here my very esteemed expert Ale, who is expert in everything that's geology, and she's staring at this map because she wants to decipher what the geology is in Brussels. One of the questions we asked ourselves earlier, and this is what she sees. That's her finger or fingertip for scale. And she's pointing at a small dot that is representing Brussels. Not just Brussels, it represents 1 million European inhabitants. Clearly, a map at a scale of 1/5 million isn't able to show geology in any kind of level of detail for that group of people. Does it mean that we just stop working, that we sit on our lazy butts and complain about that we need better maps? Of course not. We're very active, and also inside in this project, we are working hard, and we're doing things such as using or reworking that IGME 5000 map into a different type of map that helps us locate or do thematic work and helps that will in the end help us to locate these resources. But there are limitations to what we can do with what we have. If you want us to continue this work, we really need better maps. Let me rephrase that. It's not just us that need those maps, it's actually you that will be needing those maps. Let me just concentrate on clicking. There we are. And if there's one thing, if you come here to just remember one thing from every presentation, I would like you to understand that when we talk about geological maps or geological models, we're not talking about blue sky science. We're talking about things that we desperately need to research Europe, which is something that's very high on the agenda. Basically, we're talking about our bare necessities that we would like, that we all need, and if that's something, a message that sticks, then we would already like to thank you.
Thanks a lot, Chris. And also the statement on your T-shirt is also very matching today's theme.